Hello everyone, and welcome to Jam Academy. Now in front of us we have a very interesting problem. A card of mass m is moving along a frictionless horizontal surface with a speed v0 when it encounters a rough patch of the surface whose coefficient of kinetic friction varies with position x in accordance with the relation given by b minus b or bracket 1 minus x. Now we are required to calculate the work done by friction on the card, not on the block, on the card. So where do we start? The very first thing we need to do is, well, find the friction force acting on the card during the rough patch. If we do so, keep in mind that by definition, kinetic friction is equal to mu k multiplied by the normal force. If you look at the free body diagram for the card, this is mg. This is the normal force, and kinetic friction is acting in that direction. Now clearly the sum of forces along the y direction is 0. This would mean that Fn minus mg will be equal to 0. In other words, the normal force on the card is just equal to its weight. Now this is something that you should already be able to see that now. Now this would mean that the friction force acting on the card will be equal to mu mg. But what is mu? Mu is given by this expression, so this is just gonna be equal to mg b bracket 1 minus x. So the question is, what is the work done by friction on the card? Now, because the friction force is a function of x, therefore it is the force varies with position. Hence, as a result, we are bound to use the equation. We are bound to use the equation W equal the integral from 0 to x fk dx. This is gonna be equal to, don't forget the cosine theta dx. Now when you look at this diagram, you recognize that the displacement vector is to the right, but friction is to the left. So the angle between the displacement vector and friction is 180 degrees. So this would mean that W will become the integral from 0 to x negative mg b bracket 1 minus x dx. So this is equal to negative mgb, the integral from 0 to x bracket 1 minus x dx, which will be equal to negative mgb x minus x squared over 2 from 0 to x. Now we can further simplify this. This will be equal to mgb. I'm taking the minus sign inwards. So this is going to be x squared over 2 minus x. And right here, this is the work done by the friction force, which is still a function of position. Now, if you have any questions, please do not hesitate to ask in the discussion forum below, and I will be able to help you. Thank you so much, and have a blessed day. Bye-bye.